Good evening, Psychonomes. Welcome to Boston. Welcome to our 63rd Annual Psychonomic Society meeting. I'm Penny Pexman. I have the honor of being the current governing board chair of the Psychonomic Society, and we're so excited that you're here. We want to welcome all of the attendees who are participating in person this year, and as well as those people who are joining us virtually from around the world. We have over 1,700 on-site attendees, and it looks like most of us decided to attend the keynote tonight. We also have almost 700 people. The last stats were almost 700 people were joining us virtually through our hybrid options. And over the next few days, you will be in proximity to iconic Boston attractions, including Boston Common, Bunker Hill, the beautiful Back Bay area. And while I know you are here for the science, I hope you will also take advantage of all that Boston has to offer. As the chair of the governing board, it's my honor and privilege to serve the field. And while the past few years have been full of challenges, we've also got a lot to celebrate. Many of us are getting to see each other in person. The Society's journals are doing very well. We have increased citations, downloads, and shares that suggest that the reputation and reach of our science is strong and it's growing. The success of our journals is driven by the great work of this community. And we are currently searching for 3 new editors-in-chief for some of those journals. We are currently looking for editors for behavior research methods, memory and cognition, and psychonomic bulletin and review. The new editors are going to begin their service in January 2024. The deadline to apply, or to encourage someone to apply, is February 15th of next year. You can visit our website, psychonomic.org, for more information. And I do have a few more announcements before we get to tonight's main event. So last fall, the Society took over the One World Cognitive Psychology Seminar Series. It's an online seminar that was launched out of the University of Mannheim in the early days of COVID. These have proven to be fantastic talks, and they're open to everyone. This fall, we've already heard from Barbara Tversky and Carla Evans, and have more seminars coming up in the first half of 2023 from Art Glenberg, Rain Bosworth, Mark McDaniel, and Claudia von Bastein. You can get a complimentary ticket to any of these talks on our website, and you can also see all the videos of the past talks. These are a great resource, and they're available on the programs page. In 2023, the Society will be hosting 2 collaborative symposia at international meetings. The first, organized by Seema Prasad and Ramesh Kumar Mishra, will be held at the Experimental Psychology Society meeting in London in January 2023. The second will be held at the ESCOP meeting in Porto, Portugal. And if you're interested in submitting a proposal for the ESCOP Collaborative Symposium, you have until the end of the month to do so. Again, just check our website. This past summer in Tampa, Florida, we funded a Leading Edge workshop. And this was organized by Elizabeth Schotter, Brennan Payne, and Tafton Drew. The workshop, entitled Neural Underpinnings of Attention in the Real World, Co-Registration of Eye Movements and EEG, drew over 60 attendees from around the world. Co-registration of eye movements and EEG turned out to be a really fruitful and popular topic. It's one that we will share in the results. The results of the workshop are going to be shared in a symposium that is going to be held on Saturday at 1:30 in this room, so don't miss it. This summer, we started a new strategic planning process for the Society, and this will help guide us through 2030. The governing board and committees have been hard at work, and we hope to unveil that new strategic plan to you by the end of next summer. Many thanks to Erin Benjamin and Myra Fernandez, who have been co-chairs of our strategic planning process. We've also had a number of committee members, subcommittee members involved. It's a challenging but also proving to be a very exciting process. As always, we have a very full program this year. Over 1,000 talks and posters will happen between now and Sunday. We have 5 incredible live-streamed symposia, including this year's special symposium. It's titled Facilitating Belonging, Inclusion, and Equity in STEM. The special symposium will be held on Friday, 3:45 to 5:45, again in this room. Immediately following the special symposium, for those of you who are here on site in Boston, we're going to be hosting our Diversity and Inclusion reception. And it's in the ballroom of the Heinz Convention Center, so the place where the posters are held. Please join us. There'll be food and drink, and everyone is welcome. Also, for those of you who are here in Boston, I encourage you to attend our annual awards and business meeting. It's scheduled for Saturday at 5:10 in the Commonwealth Room on this floor. We're going to share society highlights from the past year, and we're also going to honor all of our 2022 award winners. I'd like to acknowledge, before I end tonight, my fellow colleagues on the governing board. If you could please stand, governing board members. I'm going to out you right now. They are fantastic, generous colleagues and have been doing great work for the society, so we are very grateful. I also want to thank our executive director, Lou Chamet, who's been with us now for 9 years. Thank you for helping us realize the vision that the governing board set during our previous strategic planning process and working towards an even better future plan for the society. I also want to thank the rest of the staff who are working very hard to make this meeting happen, including Michelle Whitworth, who's our meeting planner, and you see running around tonight. She's holding drink tickets, so you really want to get to know Michelle. Okay, enough with the announcements and the thank yous. Let's get to the science. We have a great evening planned. Jeremy Wolfe's keynote is about to start, but to get us there, it's my distinct pleasure to introduce you to Jim Pomerantz, who will introduce Jeremy. Jim is Professor Emeritus of Psychological Sciences at Rice University. He is past chair of our governing board. He's almost past chair of our finance committee and lifelong psychonom. He retired earlier this year and is enjoying traveling, visiting with family, and speaking to colleagues around the world. He is renowned for his research, for his selfless leadership, and for his allyship. He's a great example to me and to many other people. So please join me in giving Jim a warm welcome. Welcome, Jim.
Thank you, Penny. You're too kind. Let's start off with a big thank you for Penny, who's coordinated all this and is making it happen tonight. Thank you. Let me repeat Penny's welcome to the whole crowd. It's really a pleasure to see a packed room after 2 years of drought, and this is just extraordinary. I would like to underscore what Penny said, a special welcome to people who are tuning in virtually. Not everybody can make it. There are a variety of good reasons why people can't. Too many time zones away, too many other commitments, and so forth. But the talk that we're about to hear tonight from Jeremy is going to be recorded, and it could be watched later. Some people, for some reason, don't like tuning in at 2 in the morning, 12 time zones away, even to hear Jeremy Wolfe. But I think everyone will agree who knows Jeremy that it will be worth the wait. So Jeremy needs no introduction, but following a long-standing psychonomics tradition, he's going to get one. He's a fantastic researcher, a visionary leader, an engaging teacher and speaker If Psychonomics were a sports team, he'd be the one whose teammates would be dousing him with a barrel of Gatorade after his talk. Let me give you his brief bio. I'll cut it short because it's very long and we need to allow Jeremy some time to speak. Jeremy's head of the visual attention lab at Brigham and Women's Hospital and at a local university known as Harvard. He's also professor of ophthalmology and professor of radiology at Harvard Medical School. Jeremy received his bachelor's degree from Princeton in 1977 and PhD from MIT in 1981, working under his mentor, Richard Held. His research focuses these days on visual search and attention with particular interest in applied issues such as medical image perception and security like baggage screening, and that's what we're going to be hearing about tonight. Jeremy's been teaching for years, mostly at MIT. He's a fantastic teacher, but he's also a highly respected researcher and psychologist. He is a member of both AAASs, the American Academy of Arts and Sciences, and the American Association for the Advancement of Science, the publisher of Science Magazine. Just a moment here. My notes have disappeared, so I'm going to be working from memory at this point. It's always a dangerous thing, but. In putting together, I've known Jeremy for years and didn't need any additional information to help me put this introduction together, but Jeremy suggested that I phone around and ask for help from others who know him really well and might be able to give me some additional details. Now, Jeremy's a very sharp guy. He very rarely has an off day. I'm not sure what he was thinking when he suggested his son, Ben. Now, Ben, as you may know, is a cognitive psychologist. He just set up a lab at University of Toronto. And I was a little concerned. I have children myself, and if I were about to be introduced by someone, I think they would be the last people I would suggest to supply the introducer with anecdotes. So I called Ben with some trepidation or emailed him, and wow, was he ever eager to comply. And so he said, sure, and he came in with a motherload of stories and photographs and so forth. And so that's put me in a bit of a dilemma. Do I sort of defend my old pal, Jeremy, and keep this just between Ben and Jeremy and me, or do I share it with all of you? And I really don't know what to do. So what I'd like to see is a show of hands. How many of you would actually like to see what Ben sent me? Oh, it's looking good. You know, Jeremy has always been a consensus builder, and it looks like tonight is no exception. So let's start out with one picture. Everybody here knows, or certainly should know, Jeremy's work on visual search and attention, guided search 6, but you may not know that that's not where Jeremy started out. Let's see. Jeremy started out working on binocular ivory and stereopsis and so forth. And for those of you who've ever tried to fuse a Bailey-Ulez random dot stereogram or a magic eye image, you know, you have to cross your eyes in order to see that hidden image come out at you. And Jeremy is exceptionally skilled at that, as he's demonstrating here. Now, some people believe the myth that if you cross your eyes too hard for too long, that they stay stuck for the rest of your life. That is not the case. It generally lasts only 2 weeks. And so Jeremy was quickly back in the classroom after this. At one point in his career, Jeremy realized that things were really taking off. And here he is going along the beach, probably giving a talk somewhere. Lord knows where that is. Jeremy knows. Ben, you're in the room. Do you know? Okay, we'll leave it for later. Let's see. Have another one here? This is Jeremy conducting an experiment, and for subjects he was using trained, skilled archers. And the question is whether a red apple would pop out from a field of green apples. And this experiment actually turned out much better than you might have guessed. I think that Jeremy was out of the hospital and back in the lab again in a matter of a month or so. And so it was quite a success. And yes, red does pop out from green. This was Jeremy upon realizing that he'd recommended his son to be the informant to inform this introduction. So don't worry, Jeremy, I have now officially run out of time. But I did want to say that Jeremy actually has another talk he won't be giving tonight on his model, current model of attention and search called guided search. Jeremy was the first one to actually number his models. I think I was a reviewer both on Guided Search 1, which wasn't called Guided Search 1 because no one had any idea, including Jeremy, there was going to be a Guided Search 2. But I was a reviewer on Guided Search 2, and now we're all the way up to 6. So Jeremy won't have time to explain this model tonight, but if you look at it for a minute, Jeremy can answer any questions that you have at the end, I'm sure. So with no further ado, let's move on to our keynote speaker for tonight, the one and only Jeremy Wolfe.
Well, I'll be going home and readjusting the will. There are 2 other sons. Thank you, Jim. I'm thrilled and honored to be here. I'm, like everybody else, delighted to actually see live people again rather than they can't fit all this many people on Zoom boxes. It would look very, very, very small. So, I believe I have slides. Oh, I do have slides. If I go back, oh yes, those are that's not my lab. This is my lab over many years, and I'm thanking those who are in the lab now and those who have been in the lab over the years. They do all the work. I get to get up here and give a talk, but I'm intensely grateful to many people who are in this room tonight for doing the work that allows me to be up here. I'm also glad to thank all of you, American taxpayers, for supporting this. That was good of you. And I have special thanks. Well, and I now have special thanks for only one of those 2 people. But it turns out to mostly be a pleasure to now have a son and a daughter-in-law who are collaborators, and this particular talk is closely related to an article that the 3 of us published in Ticks this summer, and that's an unusual pleasure. So let's get to business here. For starters, look for the cat. You may or may not find the cat when I point to the cat. All right, that murmur suggests that it is visible here. This is a particularly useful slide because there are lots of reasons why you might not see the cat, like you might not have looked in the right place. But that bright red leaf almost guarantees that your attention will have been attracted to more or less the right location, and you still didn't particularly pick up the cat. I would guess, and you can give me a murmur of assent if it's true, that most of you probably also failed to pick up the double word typo in the slide. And well, here, let's look. Let's do another example here. Here is a lovely Giotto fresco. That changed it. I realize I changed the orientation. I just did that to hide little low-level motion transients. I can't really see. Oh, yeah, I can if I block you out. Raise your hand if you saw the change. That's pretty sad. Now, if I don't block the local transients, Whoop, now a few more people are getting it. Here, we'll help you out by not wiggling it at the same time. That's reasonably obvious. And I wasn't faking, I wasn't faking it before, right? That it really was disappearing. You also missed that typo. So why do we care? Look, I can do this all night, but why in the world do we care about disappearing angels and cats that you didn't find behind the foliage? We care about those sort of illustrations because of these sort of illustrations, among others. This is a mammogram. That if you miss the lesion in the mammogram, that's one thing because you're not an expert. But if the radiologist misses it, that's something serious. And radiologists miss these sorts of things at a much higher rate than we would like. So that's the target in this case. And we're interested in why all of us miss items with some regularity and why experts miss targets in their own areas of expertise. Now, one reason why you might miss things is because they're simply hard to see. They could be too far in the periphery and be too small. They could be crowded by other contours around them. But what we're going to talk about today are what we will call look but fail to see errors. That's language that comes from the driving literature, because that's language that the cops hear when they reach an accident scene. Officer, I don't know how I hit that cyclist. I looked to the left, I just didn't see him. So these are errors. These look but fail to see errors are errors where the image is adequate. It's not too small, it's not blurred, it's not low contrast. The target is in view, it's not behind your head. And the viewer is sufficiently expert. Actually, the idea of the reviewer being sufficiently expert, that's a different topic. And this is a real problem out in the real world. Here's a 2022 paper on the topic in the radiology literature, talking about interval cancers. Women who are in cancer screening programs in the US are typically screened every couple of years. And interval cancer is a cancer that is found in between screening. If you find that cancer, one of the first things you will do is go back to the image from the previous screen and ask, was it visible? And here you can see that on going back and looking, about a quarter of the lesions in this particular study were clearly visible on the previous screen. And they weren't missed because the radiologists are bad people or something like that. They were missed because these look but fail to see errors are an important they're an important byproduct, really, of the way that we're built. And that's what I want to talk about today. It's important outside the clinic too. Here's an example from the Ben and Anna collection of dash cam pictures, not their own driving, I'm happy to say. So if you could roll that, please. Okay, I heard murmurs that suggested that some of you saw the problem. But not, if you didn't see the problem, raise your hand. Oh, everybody thinks they saw the problem. Okay, then we don't need to play it again. When whoever was driving there saw that fire truck rather late in the business. Oops, what's happening there? Exciting things are happening. So there's this large family of look but fail to see errors. It goes from typos, the most famous example probably in our teaching repertoire is the Simons and Chabris inattentional blindness gorilla demo. If you probably all know it, but in case you don't, you're watching a video of a ball game. You're being asked how many times did the team with the white shirts touch the ball. In the middle of it, a woman in a gorilla suit walks through the game, pounds on her chest and leaves. And afterwards, you're asked, how many times did the white team touch the ball? You say, 12 times, whatever. Did you see anything else? I don't know, elevators? Did you see a gorilla? What are you talking about? 50% of people fail to have seen the gorilla. And of course, if you say, look at this video, everybody sees the gorilla. If you say beforehand, there might be a gorilla, everybody sees the gorilla. But somehow, in this situation, people routinely miss it. Now, there's this large family of look but fail to see errors. One could talk about the differences between them and talk about theories of each of these kinds of errors. But what I'm going to try to do is to bring them all together in a unified framework that I'll call normal blindness. I will acknowledge at the top here that these are not all the same thing, but I'm arguing that there is a set of principles that apply to the way our visual systems and our attentional systems work. And I really hope that the screen that just went out in front of me comes back on. It would be helpful. Oh, the rest of the slides went out too. Well, they'll be back, I assume. In any case, what I'm going to tell you is about, oh, look at that. I'm going to tell you about 4 causes of these look but fail to see errors. And those are that attention only selects a subset of what's available, that attention is guided. As Jim mentioned, I've been working for years on guided search. Attention is guided, and it can be misguided. Even if you attend to an item, it can be processed too briefly for you to successfully respond to it. And your metacognition is busy telling you that you've seen more than you have actually seen, or than you've actually fully processed. So let's work through this. Let's start with this notion of attention only selecting a subset of what's available. Take a look for T's here. You will be able to find 1 or 2, I think, 3 or 4. You'll be able to find some. I might if I keep looking. Let's go back there for a second. So, important point 1 is that you see something everywhere. Important point 2 is that you more fully process things that are inside what is known in the trade as either a useful field of view or a functional visual field. Those are roughly the same term. The idea is that if you're fixated, say, at the end of that blue arrow, there's some region around that point of fixation within which you can process items successfully. If the T is outside of that, you might not be able to find it, but inside it, you would be able to find it. Now, we know that you can't process everything that's inside that functional field, typically. We know from all sorts of, there we go. We know from all sorts of visual search experiments that you can process probably about 20 or 30 of these letters a second. That's fast. You make 4 fixations a second, so you attend to about 6 items per fixation. If that functional field contains more than 6 items, that means that you're going to move your eyes before you've successfully processed everything inside the functional field. It doesn't mean you'll never see it. You can get your eyes back there, of course. But it means that you're not going to select everything that's even everything that's near fixation. So, is there any evidence that this is a source of look but fail to see errors? Well, a simple piece of evidence would be if you do a basic T among L search task, your subjects are going to miss 10 to 15% of those trials. They're going to declare that it's not there, even though the stimulus is on until they push the button saying, no, it's not there. And those T's and L's are perfectly visible, so something is causing them to miss it. But we can put some more specific data on this by doing some eye tracking. So let's suppose that these are, there's a T circled with a yellow circle. You could be fixated at any of a variety of places nearby or not so nearby. You could be focused near, you could be focused far away. What's the chance that from the current point of fixation, your next saccade, your next ballistic eye movement is going to go to the target? It's going to go to the target if you find the target. In a free viewing situation like this, you almost always are going to fixate on the target. So what's the chance that you're going to go from any of these arbitrary fixation points to the target? You wouldn't be surprised to discover that there's a higher probability if you're near the T than if you're far away. But what do those data look like? So here's what we're going to graph. On the x-axis, you've got the distance from the current fixation to the target, and on the y-axis, you've got the proportion of the eye movements that go to the target next. And here you can see the data. You can see, yes, indeed, you do better if you're close to the target than if you're far away. But what should impress you here is that better isn't very good. You only have a 50% chance of going to the target, even if you're sitting on the next letter over. That's the data point that's 2 degrees away here. Next letter over, here's your fixation, here's your T, and you only have a 50% chance of going there. Why is that? It's because you don't process everything, even in the immediate vicinity of your fixation. Let's do the same experiment, but let's switch to radiologists as observers. This is work done with Jia-Chen Wu and published last year. So we took 24 radiologists. They're each reading 80 images, and we're going to track their eyes. The nice thing about tracking their eyes is we'll get these lovely scan pads. On these pictures that I'm showing you, the lesion, the cancerous mass is inside the red box. That bullseye says this is the case where the radiologist found it and reported it. These scan paths tell a story about the kinds of errors that people make. And there's an interesting continuum of these errors, or taxonomy of these errors, that Harold Kandel and his colleagues developed in the 70s and 80s. This scan path that you're looking at now is an example of a search error. You can see the box up in the upper right at the breast margin. The radiologist obviously looked all over the place, but not in the right place. Their eyes never got onto the lesion, and as a result, they missed it. This is, for our purposes tonight, the more interesting case. This is a recognition error. You can see that the eyes landed on the lesion and then simply moved off without reporting it. So that's a recognition error. The third type of error are what are called decision errors, where the radiologist clearly recognized there was something going on there, scrutinized it, and simply misclassified it as normal, not as pathological. So you've got this continuum. It's not the case that individual radiologists make just one kind of error. Basically, everybody makes all of these errors, and a good ballpark would be like 1/3, 1/3, 1/3 in these different categories. But now we can do exactly the same experiment. We have the eye tracking data. We know where the eyes are. We know where the lesion is. What's the chance that the next fixation, oh, I've already given you the answer to that. The chance that the next fixation is going to the lesion is, again, surprisingly low. The radiologists can have their eyes within a degree of the cancerous lesion and still wander off elsewhere, having not processed successfully what was literally right under their eyes. So, attention only selects a subset of what's available. I could probably name some people in this audience who are murmuring, "We knew that." I'd like to point out that the new bit, or the new emphasis, is attention only selects a subset of the stuff available even in that useful field of view, even right up near fixation. Okay, second point, this idea that selection is limited. Because selection is limited, it's very important to have guided search so that your attention is deployed to sensible locations, but it can be misguided. Let me give you a one-slide introduction to attentional guidance, in particular top-down guidance. In the next demo, I want you to locate Waldo the chicken here. This is a somewhat sillified version of Edith Verzian Garbett back in the 80s. So you're looking for this thing. You will find at least one, or there's two of them, reasonably easily. The important point here is not that you found the target, which is nice, but you didn't waste any time on any chickens or any items that weren't red striped. You guided your attention, in this case in a top-down, user-driven kind of way, to the red striped items. That's guidance. So guidance is great, but it's not always great. Sometimes you can be misguided. And the way to illustrate that, or a way to illustrate that, is to move to lung CT, some work I did with Traft and Drew. What you're looking at here, well, you can run the video, actually. You're looking at a CT, a slice through the lung. The black area is the lung, the red dots are the eyes bouncing around, those little white ovals are your ribs, the big blob in the middle is your heart, and what the radiologist is looking for are lung nodules, which are a sign of lung cancer. Think of them as like little white golf balls in the lung. They're small, white, and round. And I could give you a lovely talk about how people search in 3D volumes of image data. Not something that we've got a lot of data on, but we looked at that in radiologists. But what I want to talk to you about today is the last case that we did with our radiologists. Because on the last case, well, it's easier to see in a higher contrast. We stuck a gorilla in the lung. Obviously, we picked the gorilla as an homage to the Simons and Chabris gorilla. And we did exactly their experiment, right? At the end of the experiment, we said, did you see anything unusual? We did this because the clinical task of a radiologist who's, say, looking for lung cancer is to look for the lung cancer, but also to report any incidental findings. An incidental finding is anything else you found that might be clinically significant. So, if you're looking for lung cancer, no lung cancer, but there is pneumonia, you should report out pneumonia. We kind of thought if there is gorilla, you should report out gorilla. 20 of the 24 radiologists did not report it. It's important to say that this is not because they were not competent radiologists. It's to say that becoming a domain expert allows you to use your visual system and your cognitive system in a new and expert way. It does not build you a new system. It does not build you new hardware. It gives you a new way of using what you've got. And these look but fail to see errors are simply part of the way we're built. Now let's see what might have happened here. Suppose that, we're tracking their eyes. We know they fixated on this thing. They're controlling the view. It's not just coming and going. It's their, they're scrolling through the lung. The gorilla spans 5 slices. They looked at it for an average of a second, actually. What's going on here? One possibility is that you're looking at, say, that red fixation point there, and you're guiding your attention to small, white, and round, with the result that in the limited time that you're fixated there, you don't look at big, black, and shaggy, and you end up missing that gorilla. Of course, we did all the control experiments. The gorilla is blazingly visible if you have any clue that you should be looking for it. But if you don't have a clue, you're going to end up missing. So the second point is that attention is guided and attention can be misguided. Yeah, the same guy is out there saying, I knew that too. And again, the important point here is that attention can be misguided even inside the current functional field. So if you don't select the item, you're going to miss it, says my hypothetical murmurer out in the cheap seats there somewhere. The next thing I want to show you is that you can miss trivially identifiable items that you know you've been looking for and that we can be reasonably sure that you selected. To do that, I need to introduce you to a different paradigm that we call mixed hybrid search. Visual search is when I tell you look for this target. Hybrid search is when I say look for any of these several targets. And mixed hybrid search divides those several targets between categorical targets and specific targets. Here's what I mean. I'm going to ask you, you're going to do this in a minute, so start memorizing. I'm going to ask you to look for, where's the cute little pointer? This specific drink, this bell, this shoe, and any animal, any fruit, and any game that show up in the display. Is this going to be a disaster? No. So, you ready to do it? What I want you to do is clap once if you find a target, clap twice if you find two targets. You ready? The people who are online, do whatever amuses you. Okay, ready? Good, no false alarms. All right, let's do it again. Ready? All right. It's fun because you can hear the tail end, you can hear the positive skew on the RT distribution. So yeah, there are two targets there. Let's, do I have another demo? Oh yeah, how about that one? Okay, whoops, somebody thinks they found something. Oh no, all right, yeah, there's somebody out there who says, Snoopy's an animal, man, I'm good. I don't think there's nothing there. All right, let's, one more time. Okay, it's sort of a weak second clap, and I'm guessing that probably a fair number of people missed the lemon. The claim here is that you're more likely to find the specific boot than the categorical fruit, the lemon. Even though, look, once I mention that there's a lemon, it's completely trivial, right? You know that's a lemon. You know you were looking for fruit, but people miss it. And here's data to show that this is not a subtle effect. This is from a version of the experiment where most of the targets are specific and a smaller number are categorical. That just makes the effect bigger, and it's robust. Our subjects missed about 5% of the specific targets, and they missed fully a third of the categorical targets. They knew they were looking for these things. They're completely visible, and the stimulus is on until they respond. This is not 250 milliseconds and it's gone. You push the button to say whether it's present or not, and they're missing them. What's going on here? Well, this is an essentially unguided search. By the time you're looking for arbitrary animals, games, fruits, and these other specific things, there's nothing like red stripes that you can use to preferentially look at one object versus another. So what people are doing is randomly selecting among the items until they stumble on a target or give up. So that means that the probability of selecting a specific item is essentially the same as the probability of selecting a categorical item. But the probability of finding a specific item is significantly higher than the probability of finding the categorical item. Why? What's going on here? Well, let's ask a little bit about how you decide that you've got a target. We like to think about this in terms of Roger Ratcliffe's drift diffusion model, or the favorite model of yours that is basically similar to this. The idea is attend to an item, information is accumulating towards a boundary. When it hits the boundary, you say, oh, I found a boot. Okay, what happens if you don't reach a decision boundary? What happens if you're accumulating something but it never gets to a boundary? What happens if you're driving down the street and you see that thing over on the side of the road, you don't quite know what it is, and you're driving down the street? You know what's got to happen. You need to stop processing that sucker, right? You can't just be driving down the street and doing this because you're going to run into a tree. So a useful modification of the basic Ratcliffe story comes from a paper by Hawkins and Heathcote a couple of years ago. They said, yeah, you've got this process diffusing towards a identification boundary, basically, but you've got another process that's basically going towards a timing threshold that's saying, I've spent enough time with this, it's time to bail out. Now, we've known about this for a long time for the task as a whole. You've got to be able to quit a search where you haven't found a target. But the important point here is you need a quitting threshold for every item. If you've got a quitting threshold for every item, interesting things happen here. We know that it takes longer to identify a categorical item than a specific item. We can see that in the reaction time data. The information is accumulating more slowly. So if you put a quitting threshold out there, what you're going to miss are these categorical items. And we think that what causes the misses in this mixed hybrid task is just having an item-by-item quitting threshold that causes you to miss a rather large percentage of those. So let's go back to the gorilla, and let's think about the gorilla. Maybe you really did select that gorilla. It may not be a small white round thing, but it's reasonably salient, and whatever. Let's pay a little attention to it. You're accumulating some evidence about what that might be, but maybe you just timed it out. Maybe, if you look at a thing like a chest x-ray, there's all sorts of weird shapes. You could play, ooh, does that look like a duck? Or whatever. In the lung, you could do that all day long. And so the radiologist who's looking for clinically significant items might attend to that gorilla, not get any evidence that there's anything clinically significant there, and even though they attended to it, they now don't recall having seen it. Okay, so you can attend to an item and still not be able to report it. Finally, let me make a quick point about your metacognition. Your metacognition is inclined to tell you that what you're seeing in front of you is, everything. And what you're seeing in front of you right now is some really stupid chickens. So you've got a theory about what you're seeing. You're seeing some stupid chickens doing a little chicken dance. Metacognition is saying to you, if one of those chickens fell apart into chicken bits, I would have known. So, all right, I blocked it out. How many of you saw the chicken who fell apart into chicken bits? There are about 20 chickens there. There should be about 1/20th of the population who thinks they saw it. Where'd it go here? Whoops. Oh, yeah, well, actually, you didn't see that one. I hadn't gotten there yet. You saw, come on, go back. You saw this one. Twice you saw it twice, but you didn't see it. Why didn't you see it? You didn't see it because you didn't happen to be attending to the correct chicken when it showed up. But the important point here is that your metacognition lied to you. And it said, you looked at this, you saw it, you got all the information out of it that you would need. So, go away, chickens. Enough with the chickens. So, attention can only select a subset of the available stimuli. That's just the way it is. Your attention is guided. That's vitally important, or you'd never manage to get anything done, but it can be misguided. Even when you attend to items, they can be processed too quickly because you really do, under normal circumstances, need to move on if you're not getting an answer out of the current object of attention, and you believe that if it was there to be seen, you would have seen it. And the result of this is this family of look but fail to see errors that range from the trivial to the very important, and give you this state of normal blindness that we live in. Now you may wonder why this final picture is William Blake's watercolor of Moses and the burning bush. You're probably familiar with the basic biblical story. Moses is out there with the sheep, and there's this bush that's burning and it's not consumed. That's weird. And Moses says, I must turn aside and look at this wonder, or words to that effect. And when he does, God speaks to him, says, go to Egypt, set the slaves free. You know, there's a lot of important stuff. What's that got to do? What's that got to do with normal blindness? Well, in the Jewish biblical commentary tradition, there's a question about, so what's this thing with the burning bush? Why is the burning bush important? And there's elaboration on the basic story that says there were actually a lot of shepherds in the neighborhood. Most of them just didn't notice. Right? I don't know. Bush is kind of glowing over there. I don't know. And that what the divine was waiting for was somebody who managed to get past this normal blindness and see what was actually out there, and that was his qualification. Now, I do not claim that that when you go out to the reception, that if you notice that the drink is burning and is not consumed, that will be a major revelation. But I hope I've convinced you that normal blindness is a thing, and gotten you thinking about the real world problems that we might want to try to solve if we understand that this is what comes with our basic cognitive and perceptual hardware. So, thank you. Oh, there you are.
So Jeremy, I want to thank you for a fantastic keynote. We have a small token of appreciation. Jeremy has a lot of these already, but so if you have questions for our keynote speaker, he will linger for a little while by the stage, and you're welcome to come and ask him. But otherwise, you can join us outside for the reception, and thank you so much for coming.